Alright, a video on the general subject of photon interference. What is a photon? What do they say? And why do they say it? What evidence is their diagram, if you could call it that, built on? Is the evidence overwhelming? Is it even, gripping, compelling? Or is there lots of room for alternative explanations that provide a more consistent function for photons that are able to describe more circumstances without relying on made-up notions of functions that we can't not only imagine rationally, but that have no, the diagram is so unclear, so foggy, that you can't make it out at all. You can't tell whether it's tall or short, fat or thin. The description of the function is just right next to vacuously, lacking any detail or substance. So conventional modern physics, since the 1930s especially, decided to go straight ahead with two notions, relativity and quantum mechanics, based on some notion that the energy in the universe was in some wavy forms, that like on the surface of the ocean it was traveling in some lumpy fashion through space, through some kind of medium that they won't describe, they won't take account for, they just leave it to be some sort of spooky space that does these spooky things, enables spooky things to happen. And so with photons, Newton goes all the way back to Newton, the argument between a wave notion and a particle notion. The first argument I would make is that it's not even right to call something that doesn't spread, a wave. And clearly in Newton's time, they really didn't understand completely the corpuscular nature of photons, in the sense that they can be kind of extracted out of the group, and they're a tiny bit of energy that you collect and that can do things. So the impression of a light being some kind of spreading thing might have had some legitimacy, but just as easily it could be understood as being rays, and it was drawn that way. And in paintings, it's rays of light coming off the sun, in a sense recognizing that it's beams of light, that it does have a narrow function. So anyway, Newton and Huygens sort of debated over these two concepts, Newton preferring the corpuscular argument, the photon that's a little thing, and Huygens arguing for some wave notion. And then when it was found that light did move slower in materials, when we know it's not really moving through materials, it's being transmitted through them, so it's not really the same thing, but it doesn't matter. In physics, those kind of details are ignored. Newton was sort of arguing that the light speeds up in one direction, and that's why it diffracts, and Huygens argued the opposite, that it slows down, and that's why the wave bends or curves. So it was stated that Huygens was somehow right, merely because their guesses of mechanics, which both could have been wrong, because they really didn't understand what a photon was anyway. So somehow that's a big win for Huygens, even though the notion of the light speeding up or slowing down is nonsensical, in a sense that people can sort of understand that light doesn't go through glass unmolested. Glass is hard. It's a solid. It's transmitted through it. It has to interact with a lot of stuff to get through the glass. especially on the surface, and that all this reflection and deflections and all this stuff is actually happening on the surface. The layer between one material and another material is the real interesting thing going on, and it's totally ignored as as something worth investigating by conventional physics. So anyway, then Newton had done lots of experiments. He did experiments reflecting light off of glass, different thicknesses of glass. Found out that there's a probabilistic relationship between, you take a little tiny bit off and you change how reflective the glass is, and it goes through this cycle, much like the two-slit pattern, in the sense that it's it's a cycle, it's a pattern. Newton's rings made different ways, small aperture, reflecting light off lenses, finding another pattern of rings, and then also, like I said, investigating the idea of light being bent, changed, when it goes through a small aperture, or when it passes by a hair, for example, that you end up with a pattern in the light. And so there was nothing, this was something known by Newton in 60. And then in 1801, Young comes along with a little gimmick experiment with two slits in it, and shows exactly the same phenomenon, essentially, that light goes through these little slits and it gets spread. And everybody said, wow, this means something. I think before the 1930s, there was a French guy who did an experiment with just single photons, really slowing down anyway the amount of light, letting the light hit the slits over a very long period with a long exposure piece of film, months worth, and found that the same pattern is created. Now, I haven't seen any real images of this experiment. I haven't seen anybody duplicate it for some reason, but anyway, it'd be interesting to see that. But then we had also the idea that whatever this pattern was, it happened to every single photon individually. It didn't happen collectively. They weren't interfering with each other. They were just interfering with themselves, so to speak, if they were interfering. So in incorporating their wave theory, then they had to, bring back Huygens, which was sort of a dead theory just because they didn't really want to go with an ether theory, and Huygens is pretty much an ether theory. Waves, especially waves like this. That's as surface as you can get. And so they brought back, Huygens's ideas to find a justification for this pattern with a single photon, by creating this notion of wave interference and being able to split a single wave into multiple waves to explain the single slit. So the history is messy, and so you have the basic experiment, which just demonstrates the simplest pattern you can make, an on-off pattern, essentially. Nothing more dramatic than Newton's rings, than the rings you get from a small aperture, the diffraction, and that that's what you have as evidence. And yes, it's similar to what water waves do, similar but not exactly the same thing. When water waves do make lumps in the water, and they will make those lumps constructively and destructively. And the interesting thing is, this constructive and destructive thing really comes down to a kind of resonance. And so it sort of relates to other phenomenon, where you have energies that cancel out, because one's going up and one's going down, or something like that. So that's what they basically did. They turned a single photon into two photons with two opposite phases, and decided the photon somehow killed itself and didn't go to all these other places, and just went to these specific places that are on phase, and not accounting for how the photon does any of this stuff. Something that could be described as the simplest thing in the universe, photons. I mean, just really, really rudimentary. Straight line, same speed, so reliable in 95% of all experiments or whatever. Photons are dead straight, dead reliable, dead dependable, dead identical, No woo at all, no mysteries. And it's only when they interact with these material surfaces that something goes funky. And yet physics decided we're going to blame it on the simple thing, the phenomenon, and we're not even going to pay any attention to the complex matter structure that they're passing by. And the very nature of the experiment just kind of glares at you, that big aperture, very few photons hit the surfaces, very few go by the surface, close to the surface. Lots don't go anywhere near it. No problem, no patterns. Smaller and smaller and smaller, what are you doing? You're increasing the potential, the number of photons that will go near a surface. And obviously connecting this to a surface phenomenon. Now they knew this from, like I said, Newton took a piece of hair and stuck it in the front of a light and got the pattern. So we already knew this wasn't about having holes. This was about having surfaces and passing light by them. Now, if you do sophisticated optical experiments, you can also see this pattern is just created by a single surface. So the trick with a single surface is there's too much light, and so you can't see the pattern, because to have enough light to go across the surface, you end up with too much. So you have to have a very precise amount of light go across the surface to be able to see the pattern without it getting washed out. And that it can even happen in slit experiments if you don't do them quite right. So, but it's really about surfaces. Surfaces are what the phenomenon is being created by. And that's sort of what even the double slit indicates, is it has two surfaces on the inside and two surfaces on the outside. So it's really the four surface experiment. The single slit is really the two surface experiment. But anyway, so just know, just that they jumped to a conclusion. They put all these nails in the coffin, and just decided we're going to box this up and close this subject because we think we have enough evidence that it's a wave merely because it's similar to two slits with water waves. Now, we know the mechanics of two slits with water waves. We know why the waves are bulging and all that stuff. It's because of the friction and the water tension, the tension in the medium. Lots of factors that create that. And then we also know that they're not creating on-off patterns. It's one wave goes up and down dramatically, and one is flat. So there's no off-on. There's on-off in one place and nothing in the other place. A neutral. They're not really the same as photons. We sort of can surmise just by reasoning that the amount of light isn't being cut in half when you do the experiment with a photon, and so that the photons really aren't destructively interfering. They're just moving from where they were going to some new location, just like they do when you put them through a prism, or just like you do when they diffract inside of a surface or going through surfaces. Their angle, their trajectory is changed. So it's really just about a change in an angle. And that's really all that's in the math. There's no wave in the math. There's just an angle in the math. And that really does explain what's happening. It's just, 0 degrees, 3 degrees, 6 degrees, 9 degrees, 12 degrees, depending on the frequency of the light and the slit circumstances. So, sorry, this is there's a history here, and it's important to explain that why they closed this door, and to try to understand this. There's always been an objection to, I think, a particle model of reality. It made sense Newton's day even, but I think it's more extreme now, and so there's this reluctance to accept a deterministic mechanical diagram of reality, and so there seems to be this willingness to just jump to this bizarre conclusion that somehow photons, number one, are spreading in some sort of wave that doesn't spread anywhere. So they wave, that is, they go in all directions, yet they don't really go in those directions. they somehow just monitor what's happening in all those directions. And then, they do some calculus and figure out that, oh, probabilistically, it's time for me to go this way, or it's this way, or this way. And they end up pulling back all that energy that they sent out in radar somehow, and land as a full photon, one that's not tired because it was waving everywhere. Well, anyway, there's no rational way to describe it. So, they leave us begin with some drawings, I suppose. I shouldn't have had paper ready, but I don't know why I don't. But anyway, it happens a lot. So the traditional, the way they draw their photon is to do the same thing that they do with all these things. So I noticed in some of the lecture videos I was doing regarding Professor Lewin that they always draw these sine waves as symbolic representations of things that have a variable intensity or density. So they just turn a density, like it's it's thick here, and it's there's a lot of stuff here, and then there's a little bit of stuff, and less. So they draw something that has a non-wavy nature. It just happens to have a change in its density into something that's doing this, when that's not an accurate description. So they always describe photons, which they always illustrate them as this idea of two waves, two compound waves in two different fields. I didn't draw that very well. Yeah, so this one going this way, and this one going up and down. So draw a line through there and you can sort of understand it. So this one's going up and down, and this one's coming in and out. And they decide to call this a magnetic one. This would be the epsilon zero thing they're always talking about, the other weird thing that's part of Maxwell's equations. So now they're basically calling these the magnetic and the electrical constants, because they say there's these two fields that a photon is waving in. Now, they draw sound waves the same way. They draw them as sine waves, but I think somebody can understand that a sound wave doesn't travel through the atmosphere like that. The sound wave is a pressure wave, and so all it really is that if there were little dots, you could understand that there's a thick amount of dots, and it gets thicker at that peak, so it's really thick, and then it gets thin again. So you can think of it as dots or patterns, but it's not really doing a wave thing, and it's not even doing this. See, this is all automatically starting to turn out to, it can just be a straight linear thing, where there's a low density, and then the density can get high, and then the density gets low, and then the density gets high. See, all these lines should be the same. See, I'm so used to doing it their way that I can't even do it in a rectangle way. But the idea is that it gets thick in places, and thin in places, and thick in places, and that's how it moves through the atmosphere. And sound, we know, does that across a whole wave front, and that all the energy is spread over all those waves. This is real energy here, and real energy here, and real energy here, and real energy here. It's all energy, and it all lands somewhere. There's no idea that it can send out radar and then bring all this stuff back in to land in one place like they think a photon can do. So this illustration has nothing to do with a reasonable description of the physical reality. The photons aren't doing whatever this field is they're in. They're not doing this in it. They're not moving up and down and around like this. They're just a lump of compression, a compression in an ether. So there's jello, and the photon is like a thick, where the jello didn't get dissolved all the way, so the photon is like a little thick piece of jello. And that's a better metaphor probably. And the thick piece can just move through the jello without being disturbed. So again, now it's just turning back into a corpuscle. So it's so hard to describe their vision, because it really requires a medium that can be compressed, like a xylophone or something, where you can make it small, make it big, make it small. So it's this expanding and contracting medium So the photon would be a contraction in the medium where it all gets dense, and then it's light here, and then that density just perturbates or vibrates through the medium. But again, every time we see a photon, every time we really measure one, that's all it is this. It's just a clump. It doesn't spread like this. A single photon doesn't do this. It doesn't do anything like that. You need millions, billions, trillions. You need them to be coming off a source in all kinds of directions to get that effect. That's not what a single photon does. Single photons travel in rays. You know, and I would argue, in my opinion, this is just my opinion, but the evidence indicates what the photons really are is they're a clump, a corpuscle of charged energy. It's negative charge, the same charge as electrons. And the fact is, and I mean, I don't mean charged in the sense that it's incompatible. I just mean it interacts with electrons. And all the frequency is the distance between them. That's all. That's your frequency, the distance between the corpuscles. And you have 3 or 4 corpuscles in a row coming at the same direction, and that'll be called a photon. That's what you'll receive as a photon. But you need more than one of them. You obviously need at least 2 to hit an electron, and when 2 of them hit an electron, it means they hit it at a high enough rate to move the electron out of its position and move it far enough, okay, where it rebounds and then rebounds and rebounds and can readmit the photons at the same frequency or some other frequency depending on the tension of the electron. Alright, so anyway, that's one possible explanation. Certainly lots of others probably could be described that would satisfy the general features you see when a photon is actually measured or detected or converted. And usually what it's converted into, it's either stored, that is, the photon is captured for release later, and it will be released again as another form of photon, as another form of the same kind of energy, little bits moving the speed of light. Alright. Yeah, I think that covers the basics. So maybe I'll go to my notes. And so again, but just to understand, you know, they always associate waves with the water wave thing, this flowy thing. Really, that's just a surface phenomenon. Most waves, that is, most things moving at a frequency, don't move that way. They move as a compression through a medium. And that's the standard, and they spread. Those are the features. And as Feynman kind of pointed out, those are real features of waves, and so you can call them waves if you want, but they really don't act like waves. They don't behave like waves. And in many experiments, when you detect them, there's no way they could be waves and do what they do. It doesn't fit. The device doesn't work that way, as Feynman puts it. The photomultiplier, for example, doesn't work that way. All right, so sorry, you know, I can't read what I wrote, of course. Of transformation, speed of transmission. Okay, so that was the argument with Huygens. So they gave Huygens points because he guessed better than Newton, and they were both just guessing, and that's the truth of it. All right, so there's no match. So if you did waves through a single slit, water waves, so they always use this example of the double slit because there's a similarity. But in the single slit, there's no similarity. The waves come in, the waves come out, and in water waves they're bent because of the friction, because the water has tension. That is, the water molecules are tied to each other, and they're stretched essentially. When some of them are going across the surface, they're dragging across the surface. So they're just kind of stretching what would be straight waves into round waves because of the drag. Alright, but there's no interference pattern. No, as long as you keep this wavelength longer than the width of the slit, you'll have no problem. Just nice round waves, just like if you dropped a pebble in a pond. No interference pattern, no pattern. But with light, yes, the small aperture creates lots of bars at the right distance. So if you make the slit wide enough, you'll get lots of bars. You make it narrow, you get less bars. Now the key is as you make it narrow, you not just get less bars, the bars get bigger and the empty spaces get bigger. So the whole thing gets bigger as the slit gets smaller. And so that's a feature to understand. And then the pattern, when you widen the slit all the way wide, this pattern starts shrinking, okay, back to just a dot eventually. So that's the cycle of the pattern. When the slit's all the way open, there's just a dot. And then as you start closing it, you start creating a wider and wider dot, and the bars are visible, but they're barely visible because they're so close together. At its maximum, they have a certain distance from each other, and there's a lot of bars. And then as you get closer, they get thicker. So they go thinner this way and more closer together, and they get bigger and further apart as you make the slit smaller. So there's a clear relationship to the size of the slit and the effect you get. Now, there could be lots of explanations. I'll give you one quick one. Would just be that we know that these surfaces are in fact surfaces, just like when you have a transition between water and air. You'll have certain rules about how much diffraction there'll be in light, okay? And so there's certain rules about going from a lighter medium to a heavier medium, and it really takes place on the surface. And so if you just take that surface and just tilt it upright, okay, you can sort of understand that the light is essentially passing through the surface instead of going through the surface this way, the transition between, say, air and a metal or whatever you're using as a surface. So instead of going through it this way, it's going to go through it the long way. That is, it's going through it this way, and but it's going through the same. The fact is that there's every reason to believe that there's a lot of activity with electrons and atoms when there's a transition between two surfaces. So when you have two surfaces, and you're mixing, their surfaces are active, and there's electrons from both surfaces and atoms that move around between the two. So there's this mixed layer where there's a lot of stuff going on that's atomic and subatomic. And so when you have two surfaces, you could simply argue that are close together that you do have a lot of these little bits, little electrons, loose electrons, and that as you move the slits together, these electrons are repulsive, so they start evacuating to so this would be the slit wide open. The electrons are you could argue relaxed, and so as you bring the slits closer together, you can understand that the electrons are going to start feeling each other's presence. And in a sense, the air, you could say, in between. I don't want to make a statement that it matters whether there's air in this experiment, because although I haven't seen an example of the experiment done in a vacuum. So maybe the air does actually make a difference and nobody's done it. I mean, it doesn't seem that complex an experiment. There really should be one done in a vacuum jar, but I haven't seen it. So anyway, the air would have, much like a dielectric, it would be creating an opposite surface to the surface of the substance when it's, when they're just relaxed. But like I said, as you start pushing them closer and closer together, you start changing the chemistry, so to speak, the metabolism, the form of what's between these two slits. And I would argue you could kind of understand it that when the electrons are relaxed, that is, of the same pressure, then the degree angle that the light reflects at is some standard angle. And then as you compress the two, these angles start changing. That is, it becomes a wider angle. And then as you change it more, the two end up pushing, because the electrons don't like each other, the electrons end up bunching around this outside here. And so now, instead of going through the electrons that are tied this way, to the surface, you're going through electrons that are tied this way. So the tension's in a different direction now. So that's what's making the pattern become fatter and fatter, is that you're starting to go through more electrons out here and then electrons in here, because the ones in here can't be, they have to move out because they're repulsive to each other, and you're forcing them closer and closer together. So now you're hitting an electron with tension towards you instead of an electron with tension perpendicular to your motion. I don't know if you can fully see that, but it'll have to do. Anyway, I didn't want to get into the specifics of my counter argument. I mean, the real point is that they don't have enough evidence to be drawing their hard conclusion, closing the door to any discussion, completely unwilling to even, any debate, any conversation whatsoever. They're obnoxious to, and their whole theory is based on so little evidence. So anyway, so there's no similarity with the single slit. All right. So no, it doesn't match the single slit. And it also doesn't match in terms of when they do this experiment with different things. See, they're basically saying that everything, this battery, technically, doesn't know where it is. It's Heisenberg uncertainty principle or something. It doesn't really have a position. But, we can't see its non-position because, it's a big battery, and so it's being obscured by its bigness. So we can't see that it's, being affected by these things. And that somehow everything has this wave function. That is, everything is sending out this radar waves in all directions to decide where it's supposed to go. So they think that's happening with electrons, and then they think it's happening with even small atoms when they send them through. Now, the first thing to understand, the pattern is completely different for each thing you use for the experiment. Photons create a certain really bright bars, really straight little dark lines. Electrons create a more sinusoidal, that is, sinusoidal this way, light, dark, smooth transitions from light to dark. And the big atom things create almost it's barely a pattern at all. You can't, you're sort of guessing. Yeah, maybe pattern, maybe not pattern. 50-50. It's really poor. And those are all important facts, because they sort of tell you that why is the pattern so sharp with photons? Well, because photons when they interact with electrons, are the most interactive thing with electrons. Okay, I mean, that's what they do for a living, is move electrons. Now, when electrons hit each other, the trick is that electrons are charged, so they have a repulsive force field of photons, essentially, coming out of them, and they'll reflect off of that force. The force of the photons coming out of the electron will essentially push the other electron, and photons, I mean in the loose sense. They're not photons like in the form of a frequency. They're the little bits of energy, just like a photon, except they're not necessarily at a set frequency. But anyway, so that's what they basically bounce off each other's force. They never really hit each other. And the closer they get to each other, the more pressure they create between each other. So like elastic bands, if they get really close to each other, they'll shoot apart at tremendous speed, because all of the energy going in will be conserved, and it'll be used to shoot them back out. So they never collide, really. So you can understand, well, that's why the electron pattern is smooth, is because electrons slide off of each other. They don't have they're not a corpuscle of energy hitting a bigger electron and giving it a bit of momentum in one specific direction. They're a more complex thing that already has maybe a little bit of jitter and movement, and they're going to bounce off of each other, and they're going to share their energy. The energy from one electron is basically going to be shared with the other electron, so they're going to split the energy between them. So that's why the pattern is very different. And then you can say with atoms, clearly when they hit electrons, in between a slit, they're going to have the same effect because the atoms have electrons on their shells. Those shells are going to react to the electrons, but the electrons in the field aren't going to be very strong, so they're not going to be able to influence the atoms very much, and that's why you have an incredibly weak pattern with atoms. So all of that matches. Yeah, if you just say yes, it's interacting with the surface of the matter. The surface of the matter is a complex field. It's a transition between two substances, which is always a complex bit of space. And it does a lot of things, and especially it does a lot of things depending on angles that you come in and all of that stuff, and yet we are to accept it's waves, it's waves, it's waves, it can't be anything else, there's no discussion, we've closed the door. Alright, so anyway, again, the single photon thing is sort of critical evidence that should have led people to the conclusion, maybe this isn't about waves. Maybe this is about the surface, because that's the only thing individual photons would have in common, is they all went by a similar surface. All right. So refraction through smooth versus rough surface. So we have examples of that with refraction and light. We know it doesn't transmit through something. If I screw up the surface of glass, the light scatters. I can do lots of things, little subtle things, dramatically changes where the photons go. So photons are completely susceptible to just little variations in the character of a surface, little changes. Alright, it's about surfaces and, not holes, not slits, not any of this stuff. The surface is what's causing the phenomenon. The surface is an active place. The photon hits electrons. When photons hit electrons, they get absorbed by the electron, and then they get quite possibly readmitted by the electron. So all the things you see them not because the photons bounced off literally. You see them because the photons were absorbed and certain photons were thrown back. That's what you're seeing. You're seeing the photons thrown back at frequency. That's what you're seeing. You're not seeing anything else but light that was absorbed and gets readmitted at a chosen frequency by the electrons. That's why some things look green and some things look something else, because it depends on the character of the electrons the photons hit. Alright, Alright, so you have the index of refraction for transitions. So that's the important thing here. This is just about, you're going through a transition surface. We know transition surfaces deflect, reflect, cause a deflection in photons, and that it is all about the surface. And the surface angle will dictate whether, how the photon is reflected, how the photon is absorbed and readmitted. But I would argue it's always absorbed and readmitted, or it's absorbed and converted into infrared or something else. So it's either admitted as a photon, or it's absorbed and readmitted as infrared radiation, creating heat. So it's still a photon, essentially. Alright. No explanation for lost energy, so I've sort of explained that, but this whole colliding wave interference theory is dependent on a bunch of stuff doing stuff, a bunch of invisible ESP energy. So again, this is just woo physics. These magical forces that are flying around doing something, magical perturbations inside of forces, and somehow, besides being there and not real, okay, then they're also retractable somehow. Somehow they're not made out of real energy. They don't require real energy. There's just no way to make any sense out of it. It's such a bizarre explanation. It's an extraordinary explanation, and it should require at least ordinary evidence. and they don't even have that. So they're giving you a complete UFO theory, and they're not even giving you anything hard as evidence, any real substantial pile of evidence. They're just giving you this vague little similarity between surface water waves and photons in one circumstance that isn't comparable to all these other circumstances where there is no match, where there is no similarity. And they just ignore the evidence against, and the only thing they pay any attention to is the evidence for. Alright, the idea of light plus light, making dark is stupid. That, somehow the photon is destroying itself, or its copy of itself, or whatever. Two copies crash into each other and somehow create dark. So again, it's not what happens. There's no, unlike in the waves, it really is that. It really is that energy going one way hits energy going the other way, and the two pieces of energy crash right into each other and annihilate because they're going in opposite directions. You can sort of understand how, yes, two things could bang into each other, and there can be a loss in the sense of, it's not the best way to say it, because you two hard things, obviously, there won't be any consumption of the energy. But energy is basically imbalances. That's when you see something. It's when something's imbalanced. And so if you balance it, then it's back to neutral, and that's sort of the point. So you have to sort of think about it as a third party. So there's a third thing moving, and you hit it with, well, no, I won't go there. Now I'm just going to confuse it further. Well, anyway, the point is that in waves there's real energy consumed when the two waves fight each other, but in water. But that's not true in photons. And it's not two photons, it's just some sort of bizarre thing called a wave function, a probability wave. Just terminology with absolutely no physicality, nothing that you can understand as a real thing. Alright, moved. So that was this is a key thing to understand, is that what's happening in the light experiment is that instead of going to one location, the photon is deflected to another location. And I mean by deflected, it's absorbed by an electron, wobbles the electron throws the photon back in a new direction because of the direction of its wobble. Alright, so then beam splitters. I could go on a whole subject of just beam splitters. I could do a page on beam splitters. The very notion of it, the unprovenness of it. So all of these experiments, a lot of the interferometers, the other experiments depending on notions of using this wave interference notion in some way, are all dependent on this idea of splitting a beam of light, a bunch of photons coming in, and somehow you're going to cut the beam in two. You're going to have half the photons go one way and half the photons go another way, and the photons won't be changed in any way by the process of being forced to take a right turn. So somehow you can change the direction of the photon 90 degrees, and we're to believe nothing else changed. There's nothing else changed in the universe. You didn't change the machine that's doing the filtering, the machine that's moving the photon 90 degrees. You didn't change its position or how it functions, so it changed for the next photon that comes along, or you didn't change the photon itself in some way. It seems that highly improbable that is possible. So I'll do a brief on the interferometer, but the idea of the beam splitter is what I really want to get to. So the original one for the Michelson-Morley experiment, which was famous about disproving the existence of ether, which is ironic because all of the theories they have, both in quantum mechanics and in relativity, are ether. Spent space is effectively an ether, and the idea of an electric and a magnetic field is again just an ether. A field of what? a field of ether, a field of something that your light is waving in, right? You can't have a wave unless you have something to wave in. And so it's just ironic that they have full confidence that there's no ether, and yet they just have relabeled that your ether field or space. But it's the same thing. There's no difference. So it is all kind of bizarrely ironic. So anyway, Michelson-Morley was the first fancy use of this idea that you could do measurements with photons to measure changes in distance. And so the idea in the crudest form is you send light into this magical thing called a beam splitter, and the light goes perpendicular and one beam goes straight, and then you have a series of mirrors and you bounce the light around, and then you send it back to the same through the same process. So you have mirrors and you send it back, and you're measuring the distance distance in length, any change, vibrations in these mirrors. So vibrations going this way or vibrations going this way will be indicated by the fact that these light will interfere with itself and create a pattern because it will be out of phase. Okay, so the clumpiness of the light in space won't line up. So instead of being in alignment, the photons will no longer be in alignment, and that creates your interference pattern in theory. And so the idea is it goes through this thing, bounces back, then comes back again, and the two beams are in a sense recombined to an output path. Even though they also come back this way, they don't pay any attention to that beam. So anyway, so the two come back, and this is what creates a pattern of rings. Now you don't need to do any of this stuff to create exactly this pattern. All you need to do is have a piece of dirty glass, and internal reflections will create exactly the same pattern. So the point is in Michelson-Morley, the idea was to measure light traveling the same way as the Earth is moving. So the Earth would be moving in this direction, and so therefore there should be a path length difference between this path, and they couldn't find any of that path length difference. All right. But the real point is the beam splitter. So the beam splitter they were using is a half silvered piece of glass, which is basically means there's a bunch of little dots of silvering and that add up to 50% coverage. And what are those little dots doing? Well, if you blow them up, they're basically creating a bunch of single slit experiments. So between the dots are little gaps, and those little gaps are exactly like a single slit experiment, just exactly like creating two surfaces and then having light go through it. And we know that if you do that, you'll get all kinds of diffraction. So clearly a beam splitter dependent on this function. Okay, so the light will come back reliably off the mirrored bits. That is, mirrors are pretty good at absorbing light and throwing it exactly back. But the light that goes in between the gaps, that light is obviously going to get, some of the photons will be spread a lot, some will spread a little, some will go straight, but there are going to be lots of variation in where the photons go. And so the problem with the experiment is that the one path, the light spreads through the whole experiment, and then it goes through the mirrors, spreading, and then it comes back again, and it's spreading huger and huger. By the time it gets back to the beam splitter, it's got a huge spread in it. And so now it's if you cast a picture of it on the wall, the beam is a big, thick beam. And the beam that went this way, they took the other path that bounced off the mirror first. So one beam goes through the gaps, gets spread, comes back, spread. The other beam comes off the mirror, goes through all the other stuff, comes back, and it's still not spread. And it only spreads, going this last little length is where it spreads. So it spreads this tiny distance, where this length spreads through this whole thing. So the two of them, when they're combined, if they were to be combined, one beam is a very narrow beam, and one beam is a huge spread beam. You know, photons spread out in lots of different, and the key thing is that these are angles. This is a cone that has been created, you know. And so the trick is that yes, this device can measure things, because as you go distance, so as a photon travels distance, this spread will tell you how far it's traveled. So if you can just measure how wide this is, you're also measuring how far the photon traveled. So that's why it's a good ruler. But it's a ruler. It's not a micrometer. Okay, it's nowhere near capable of measuring wavelength differences of photons that they claim it can do. So they have this, you know, thing engineered in such a way where they think it can measure, you know, preposterously tiny movements, when they have no evidence can do any of that. So the LIGO thing was never tested with any real sounds or noises. They never made a noise in, say, San Francisco and decided to see if they could hear it at their LIGO machine. So there's no real testing for the sensitivity of this thing. They just make claims that they can detect the movement of a, you know, the tail on a horse, tail on a unicorn from Alpha Centauri. They can see that movement with their device. Well, anyway, when in theory it's not really possible, because the two beams aren't equal. And see, the other key thing, when photons travel these longer paths, those longer paths are going to change the phase of the photons, obviously. So the straight line is shorter than the crooked line. So obviously there's going to be a phase difference in the photons. That is their alignment again. So again, the idea is they have to be aligned, and what's happening is now they're out of alignment because one traveled further than the other one traveled. And clearly that you'll create that phase difference with divergence. So if the beam's diverging, it's automatically creating a phase difference. Even in the beam itself, the stuff in the middle will be out of phase with the stuff on the edges. So you don't even need the other beam, because you already have potentially interference in the one beam. Alright, I didn't want to get too lost in a bunch of interferometer stuff, but I just mean that none of this stuff has been thought through, fairly analyzed, fairly understood. So in theory, so this very famous experiment mentioned by Einstein and Maxwell and all the famous people and Lorentz, everybody, and here theoretically it couldn't work as described, because it's not creating two equal beams. And it just has to be conceded. They're not the same at all. They have a fundamental difference, a huge difference, in that one is spreading dramatically and one is not. Alright, so no equal beams. And the other beam splitters rely on thin film, so I don't want to get into all that. But that's a whole nother thing. You could go on and on, the whole subject on what happens with these thin films, you know, but a thin film between two thick films, you know, two thick surfaces. And the idea with the thing with thin films is you can get lots of internal reflections, because at angles the light can reflect for lots of perturbations, and it just depends on it as you change the angle. So diffraction, as the light diffracts, that means the angle's changed, and as you change the angle of something, then you're more likely it's going to reflect. So as the angle becomes sharper and sharper, the odds of reflection go higher and higher. So there's a, you know, as soon as you start going off perpendicular, you start increasing the likelihood of a reflection, and that happens inside the glass surfaces also. So they can have very probabilistic outcomes, where there can be 1 in 100 reflections before the photon pops out, or it can be 1 in 10, or it can be, you know, so it can be all kinds of numbers just depending on the angles. All right. What the hell is that word? Okay, so it's the interferometers it's just an exaggeration of their precision. And there's no explanation for where the light interferes with itself. There's no explanation of whether an interferometer works with single photons. there's just nothing provided. I mean, they don't give you any explanation for where in this process the photons turn into a wave function, where they Huygens and turn into a million little wavelets, and then they combine back into a regular photon again. There's no explanation for where any of this stuff happens. Alright, so thin film, again, that comes back to the index of refraction and the angle of reflection. Really important stuff. So obviously, if I'm causing light to diverge, I'm changing angles, and as I change angles, I change the likelihood of reflections. All right. Let's see. Trust them regarding. Okay, so they do have some experiments now that they've done, they claim, where they've taken different photons and forced them to interfere with each other. But they're all very complex, using fiber optics and all kinds of nonsense, all kinds of more complicated experiments than the single slit or the double slit. And you can see that when they describe the single slit or the double slit, the professionals, they always do it inaccurately. They always say, well, if you cover one of the slits, you'll just get a blob of light, when that doesn't happen. That's violating Newton's observations. Clearly that doesn't happen. But they just say it because it makes their argument. So here they can't describe the simplest one, the simplest experiments you could do. They can't accurately or honestly or carefully describe it or understand how it works, and yet people trust them when they have these terribly complex. LIGO is insanely complex. The noise filtering is impossible in a sense. Like somehow they're going to figure out all the noises the universe makes, and they have a record of them all, when they can only have a recording of noises for like 20 years or something worth of reliable ones. So what about the noise that happens every 50 years, or the noise that happens every 100 years, the noise that happens every 10,000 years? There's an infinite number, almost, of possible noises that can show up at any one moment. There's geysers that explode every 10,000 years. So, and maybe you show up on the day it explodes. So, how can they anticipate all that? They can't, and yet we're supposed to trust them. And so we're supposed to trust people. They say, okay, I've made two photons, individual photons crash into each other. There's no evidence they've done any of that. And they always require these crystals. They have these magic crystals where they shoot a photon in and then two other photons pop out. And they assume they're coming out at the same time, that they're in phase, when they really don't have any evidence of any of that stuff. So anyway, but all this trust. So they can't do simple experiments fairly and honestly, and yet you trust them with insanely complicated experiments when they say we've done it. I don't know what to say to that, except that's an unreasonable lack of fair scrutiny. All right, so I've already pointed out photons don't really reflect. They're always absorbed, and it's just about how long. So how long they're kept. How long their energy is kept by the electron, moving the electron. And that's really all there is. But they're always absorbed and then readmitted. If you see them reflecting, you're seeing a readmission. So, I don't know, spooky explanations. Yeah, so this whole interference thing is just a spooky explanation. And apparently that's all people want. It's just give me a mushy, silly, outlandish UFO description of reality. Alright, electron, and I guess I was talking about the atoms and such. I think I already did that. So, I don't know. So they have a reasoning bias, is my argument. And that can be the only explanation, because the evidence is so bad that they obviously have a bias. They want this to be the truth, and that's all this really has something to do with, is that somehow they like this silly explanation, because the evidence is so weak, so inconsistent, creates all kinds of it forces them to create all kinds of spooky explanations just that don't make any sense. Yes, single photons interfere with themselves. Well, yes, and then other photons can interfere with each other, but only under special circumstances that, so it's all this inconsistent theory. It doesn't match. You can't make it make sense. And everybody just falls for it, and they don't have any will. Again, there's zero will to engage in any kind of conversation about the fact that these experiments contain energy, photons, interacting with matter. And again, their conclusion is the photon does all the tricky stuff, and the matter is just a victim. He's just sitting there minding his own business. I was just making a slit, and the photon did all this crazy stuff. As if the matter doesn't do anything, doesn't have a function. As if it really, as if the surface of this pen really is a smooth surface. They're physicists, and they really think this is just smooth plastic, and then there's air. There's no atoms with electrons on the outside. So they don't even understand that part, that even if you understood it as atoms, all having little orbits, that you'd have to concede that the edge of a material would always have to have electrons on the outside. There always has to be electrons on the outside. Always. So, anyway. I mean, their own model of the atom dictates that the nucleus is a billion miles from the nucleus, the electrons. So you can just sort of understand there's no way to make the electrons orbit and have the proton near the surface. It just can't happen. Logically impossible. All right. So anyway, I think that's probably enough. So I'll revisit these subjects. I plan on doing a few of them, but I just thought, as I progress through this thing, there's more and more things I recognize. And I think an important thing that I did try to emphasize a little bit is the idea of resonance. This idea of constructive and destructive is the same thing as the idea of resonance with sound waves and other kinds of force, in the sense that there's stuff that isn't banging into each other, and then there's stuff that's going in the same direction. So it's like forces can push in the same direction, and they won't weaken as much, because they're not pushing against each other, doing this as much as if they're doing this. So if they're going against each other, they're going to consume energy, in a sense. They're going to make energy disappear, in the sense they'll put both things back to being neutral. I got to try to explain this in a way that, you have to understand it's not like kinetic balls. It's absorptions. So when two things going the opposite way hit each other, material things, that's what you get. They're done. They annihilated their disproportional energy. So there is no bouncing off. It doesn't happen. They don't reflect the energy. They let it pass through, in a sense, and they stop moving. They give it back to the field. All right. And as heat, and that's something you understand, is when you have stuff that you have destructive interference, you end up creating a lot of heat, because now you're releasing a lot of the motion of atoms and converting it into energy, because now the two atoms that hit each other released energy instead of moving away from each other again. Instead of bouncing off each other, they released the incompatible this way and this way energy got released, and they're left not moving. So again, the point, but so it's much like this whole argument about interference is really about this idea that you can have a perpetual reflection if you don't waste your energy in something where you're having friction either against, in the case of a rope waving, it would be the pieces of the rope going in two opposite directions. If the movements are always complementary, then the energy won't be released. And no heat. Probably I didn't do that as articulately as I needed to, but I'm just saying the point is that as this, over the months, I do acquire insights that I think are important, and I think that's an important thing to understand about resonance, is that it's about the fact that a reflection can be maintained if it's always complementary to the thing it's moving through. So if it's in phase with the energy being put into the system and it's in phase, then it's complementary, and it just keeps going back and forth and making it more and more energy inside the system. See, it'll never be in perfect phase, so there's always some losses, but I just mean you're keeping more than you're losing, and so the reflection can be maintained for a longer period of time, which means that as you put more energy in, the old energy is still going back and forth. You can sort of understand, it just magnifies how much energy you can have in a system when the energy isn't colliding. The energy in the form of the movement of a matter. So this is where it gets complicated. And so again, but it's always conversion. So if you have destructive interference, you have heat. You have energy released. Because it can't be destructive if it doesn't annihilate the movement of the material bits. So if the material bits don't have their movement annihilated, then you can't call it destructive, because then it still goes somewhere. It's still moving. That's the point I really wanted to get to, but I just didn't do it very well. So anyway, till the next time. And sorry, I don't know why this camera's angle is less than perfect. The frame rate's too slow, and the light's too washed out. I don't know. Got to fix that. I don't really have to, but yeah, should.